So I'm Mike Hirschberg. I'm the executive director of the nonprofit, the Vertical Flight Society, and we're all about vertical flight, so whether that's electric or drive systems or anything else. We're not really a power systems technical society. We're really more on aero. So we started out 75 years ago this year as the American Helicopter Society, and it was really as sort of like maybe in a community like this where the first helicopters were starting to fly, and they were starting to have different companies that were actually starting to put together products and starting to work with the military services and operators, and there needed to be a community for working together and helping to advance the technology and understand the physics and how things worked and the business relationships and stuff like that. So basically the founders of the American helicopter industry started AHS. And basically on our 75th anniversary, I finally got the board to approve a change of the name to the Vertical Flight Society. So it's really going to be effective as of January 1st, but we started going by the Vertical Flight Society as we transitioned, because really, even from the beginning in the 1940s, it was during the war, we had British and other allies that were part of the American helicopter industry and AHS. And even from the 1960s, with all the work on shaft-driven vertical takeoff and landing aircraft and jets, that was also part of the purview. So certainly as electric power has advanced, both from the micro scale to eVTOL and other systems, electric VTOL is definitely part of our domain. So as mentioned, we're a nonprofit. We're an educational technical society. So we work to promote vertical flight, its application, understanding the technology, and around the world we have scholarships. We have student design competitions. We have lots of development efforts for students and professionals for both today's engineers and tomorrow's. And we lobby, we advocate for more research and development funding for NASA and the DoD, and things like safety, noise, acceptability. We have a magazine as well, and I brought about 50 copies, so those of you interested in VTOL, we've got a selection there on the back counter. But it's all kinds of, looking at all kinds of technologies, disruptive technologies, new technologies, improving existing platforms, and also imagining new types of vertical flight aircraft. And certainly as things have progressed over the last 5 or 6 years with vertical flight applications of electric and hybrid electric, we've also been working in that area as well. So we just had our 5th annual what we called Transformative Vertical Flight workshop, and we've renamed as Electric VTOL Symposia because symposium is a better word than workshop, and it's a little more specific. So 5 or 6 years ago when we started the series, I wasn't quite sure what exactly it was going to be, but looking at novel types of propulsion systems. But things have really changed, just been a real inflection point over the last few years, especially as some of the companies who have been developing and demonstrating technologies have come out of stealth mode and been more open on what they're actually doing. So we have an annual forum, which is actually next week, so in Phoenix. So if there's anybody here that's interested and isn't doing anything else, next week we invite you to come to Phoenix. It's looking to be a jam-packed, it's really a 5-day event, and we have basically the leadership, the executives of the helicopter industry, which now they're all vertical flight companies really, and about 250 technical papers, so 8 parallel technical sessions and a CEO panel, all kinds of exhibits, the whole 9 yards. We also have technical committees, so different things like propulsion, unmanned systems, autonomy, acoustics, which Ken talked a great deal about aircraft design. We do now have a committee we've started, actually a few years ago, but on electric VTOL. So those of you who are interested in this space, whether you're a technical expert or not, we invite you to come and check us out. So my involvement with VTOL actually goes back to about 1990, I guess it's about 1994, 1995, and I guess, yeah, beginning of 1995, I started working in the JSF program office. There was this VTOL wheel of misfortune that had been developed in the 1960s and 1970s and updated, looking at all the different types of aircraft that could combine the vertical takeoff and landing capabilities of a helicopter with a high-speed forward flight of a fixed-wing aircraft. And it was called Wheel of Misfortune because at the time there were only two successful concepts, really only one successful concept, the Harrier, that went into actual operational service. When I was in the JAS program office, we were trying to be basically the next one. So the Harrier's down here, and this is a propulsion, hierarchical scheme of how to break down the propulsion systems. And I should also mention that in the current generation of electric power and hybrid electric and VTOL and CTOL, there are different terms. There's a technical difference between a rotor and a propeller and a fan. Unfortunately, quad rotors are not rotors, they're propellers, but there are actual words for some of these things, and some of these terminology about whether it's lift plus cruise or lift plus lift cruise. These different terms, they actually do exist that are applicable to the vertical flight, and I'll have a few of them later as far as for eVTOL. But the reason why most of these concepts were unsuccessful, and another reason why it's called misfortune, is because a lot of people died in testing these. There's a cargo plane, sort of like a small, a vertical takeoff and landing cargo plane, sort of like today's V-22. They built 5 of them, and they had, I think, at least 5 accidents, and several times people were killed. And the reason why that was is because you had, the Harrier was successful because it had a single engine, had 4 nozzles, but it had a single engine, so there was only a single point failure. Some of the aircraft, the XC-142 that they built 5 of, it was a tilt wing, so it had 4 propellers, and they're all cross-linked. So if one of the engines died, that they could still propel the other ones. But shafts would, the transmissions would seize up, or then the wing flexing as it's hovering they would break disconnect the bearings and such. So all those mechanical linkages were lots of single point failures. So it's really interesting now with electric propulsion. You can really kind of throw out the 100 years of design manuals of how to design an airplane. You can come up with these new designs for either electric CTOL or electric VTOL or electric STOL, of all these different designs, because now it's instead of power by transmissions, it's power through cables, so it's power by wire instead of by shaft. So it's just really very interesting to be able to decouple that and have distributed electric propulsion. And so I think now, so this is really looking at the wheel, which you can download here from our website, vtol.org/wheel, and this is a clickable map, so you can find out information about all the different categories in the aircraft. But the point being is now, I think in the 21st century, this new sustainable aviation capability from electric power, there'll be a new, and we're kind of working on it, but the new eVTOL Wheel of Fortune. So why now? You guys are, a lot of you are probably much bigger experts on this than I am, but why is this capable now rather than in the 20th century? Well, certainly there's incredible advancements in electric motors and batteries, computer controls, modeling, simulation, composites, 3D printing, and low-cost manufacturing. This potential change to FAR 23, or the change to FAR 23, that appears that the FAA is receptive to having that apply to VTOL aircraft as well, which is really game-changing. Lots of technical ideas, and that's just a fertile ground for new and novel concepts. And then technology investment. So you see here Starman, okay? So Elon Musk made a ton of money with not PayPal, but he made there's all these people in this area, especially in Silicon Valley, who have made billions of dollars in apps that now want to provide those resources to solving issues for the 21st century, like sustainable aviation, like space travel, things like that. So it's just there's this huge wealth that's been generated that can be applied to these problems, and all these combined enables new configurations and new innovations. We did mention, somebody mentioned before, electric helicopters, so this is not what we're talking about. Yes, you can make a helicopter powered by batteries, but kind of why would you want to? So this is a picture from almost 10 years ago that Sikorsky had when they never actually flew their Firefly, but this is taking out, these are all the parts down here that they would take out of the helicopter if it wasn't fossil fuel burning. And they had two big batteries here on the side at the time. But this isn't what we're talking about, because with power by wire, you don't have to use a single main rotor, so you can get rid of all the complexity. Oops, that wasn't what I intended to do. But you can get rid of all the complexity that a helicopter. The difference between a propeller and a rotor is that a rotor flies sideways. I mean, it creates thrust and lift and directional capability, so it has a lot more complexity to be able to do that. So with distributed electric propulsion, you can create this this really complex rotor and have lots of simpler thrusters. And one of the things that maybe wasn't clear, this is really the thing, is helicopters are not efficient. It was the professor before was talking about the comparison versus a rotorcraft versus a wing. So yes, if you can fly on a wing, you can get much or more efficiency. Something that's only uses thrusters, doesn't have a wing, is going to be just as inefficient as a helicopter. And huge reductions in noise. So we'll talk about Uber in a minute, but that is really the linchpin for the Uber Elevate. There are dozens or scores of helipads in San Francisco and in LA and other cities, on rooftops. It was a law for a long time in California. If you had a high rise, you had to have a means of evacuation. But nobody can use them because they're too noisy. Helicopters are too noisy to be used in urban environments because of the community noise about helicopter noise. So if they were essentially inaudible, or over background traffic noise, that's really what, like I said, that's really the linchpin of Uber's operations, is to be able to do. It is a short hop, so it's 30 miles from rooftop to rooftop across cities, so you're not stuck in traffic. If you can go from San Jose to Fisherman's Wharf in 7 minutes by flying 200 miles an hour or whatever, there's tremendous benefit to those people that are able to fly. So we're not talking about helicopters. We talked about horseless carriages at the Uber Elevate thing, and cars are not buggies with mechanical horses, unless China, they'll invent anything. So there's a mechanical horse there, but that's not what we're talking about here. All right, so just a little bit of prehistory or back to origin. So like 2010, 11, things first started to gel. So NASA did a study looking at a single-seat electric VTOL aircraft called the Puffin. And that was kind of a thought piece that Mark Moore at NASA at the time came out with. And that was to some degree some of the genesis with Larry Page investing in Kitty Hawk and Z Aero at the time, and some of his electric VTOL work. A relative, pretty conservative helicopter company, Augusta Weston at the time, now Leonardo, developed this electric-powered tilt rotor, which has had so many different innovations. They did fly it unmanned. This was a full-scale one that would have been sized for a single person. They didn't do conversions on a full-scale one, but they did for subscale ones. So this was the world's first vertical takeoff and landing helicopter, eVTOL, eVolo at the time. They renamed themselves the Volocopter. They had this crazy thing of taking a bunch of electric motors and propellers, and that really is a yoga ball that the guy's sitting on. I mean, so this was like, I don't know what it is now, but it was like, within a year or so, it had like 10 million views on YouTube. So it was just, what is this? This is just so crazy, and it just kind of melted my brain and a lot of other people's of saying, this is weird. This is crazy. So a few years later, again, Mark Moore at NASA helped steer this project, Grease Lightning, which is a 10-foot wingspan, distributed electric propulsion, proved out that. They did do conversions in 2015. This in 2014, this is about the time we had our first transformative vertical flight workshop. So before they actually had started flying it tethered, we were saying, we think there really is something here. So we gathered the enthusiasts and researchers to bring this together. Meanwhile, Volocopter had taken their yoga ball and inverted it and had something that they started flying and manned in 2016. So that was pretty impressive. Let's see. So I mentioned Larry Page at. This is the second time I've gotten a call while I'm giving a presentation. Larry Page, had gotten, I think the story goes, had gotten inspired by the Puffin model there, started investing hundreds of millions of dollars in vertical takeoff and landing eVTOL research aircraft. I guess in March, about 2 months ago, they unveiled that they've been not only been flying their single-seater and unmanned versions for several years. We're now flying this. It's sized for 2 seats, but it's being flown unmanned. So they've built several aircraft in I guess in Mountain View area, so just a few miles from here. They also debuted this actually earlier in April of 2017. This basically a flying Sea-Doo. And this is a kind of a proof of concept. I said prototype. It's really more of a proof of concept aircraft, and they are actually it's less than 250 pounds, so it's already it qualifies for the Part 103, which has to be less than 250 pounds. So they feel they've got a product that they can bring to market on this, and this is a recreational model that you'd be flying over lakes. And mentioned Volocopter. Sorry, it's a little bit out of order. And at Consumer Electronics Show in January at CES, it was almost the first time that one of the first times that aviation had been at CES, and certainly in those larger numbers. So Bell used to be Bell at the time. It was Bell Helicopter, now just Bell. Had the fuselage of their eVTOL concept that they're developing, and one of the applications is the Uber Elevate mission workhorse. They have a quadcopter, and the eVTOL guys flew theirs actually indoors. Another company, A-Cube, which is the Silicon Valley subsidiary of Airbus, has been flying their Vahana aircraft. This is a size for a single seat, but their concept now is that it makes more sense to have probably 3 or 4 seats for an actual product. So Aurora Flight Sciences, they're actually near us. I'm from the DC area. They're in Virginia. So about a year ago, they flew this quarter scale model, and it was this is it as well, but applicable to kind of the Uber mission of about 4 passengers. They've done some changes to their configuration, which I'll show in a minute. In Santa Cruz, Joby Aviation has been flying their S4 on February 1st. There's a big unveil, both with a couple of press releases and in Bloomberg. Again, this is a demonstration flight of their 4-seat. This is the report by one of the reporters. A pilot managed to take off, vertical takeoff, 15 minutes of flight, 15-mile loop, safe landing. Basically, and fly at twice the speed of a helicopter while making as much noise as a swarm of super bees. So I don't know how loud Super Bees are, but I guess he was trying to say that it was quiet. You can see the comparison. This is a scale drawing of the S4 and the Robinson R44, so both four-seaters. This is 6-propeller tilt rotor, single main rotor, Super Bee quiet, 250 miles an hour and versus 135 miles an hour. But the difference is also this is much heavier. I think it's about 4,000 pounds range for their S4. And I neglected to mention that we have on our website, which you'll see in a minute, but we have a lot of information on these aircraft. This is a CFD diagram or simulation of what the airflow would be with the 6 propellers in hover mode. They had originally looked at a 2-seat aircraft called the S2, so S4, 4 seats, S2, 2 seats. And they had done, I don't know if you can see how well you guys can see that, but that's what, the propellers would tilt down and then fold up, and then there would be some just the wingtip, small propellers would propel it forward for forward flight. So they're not, I guess they haven't announced too much or talked too much about the S4, so it's not sure how much of that folding and tilting part is involved, but again, it's definitely wing-borne flight is key. German company Lilium Aviation, they had built this aircraft. Again, they flew it unmanned, but it was sized for 2 seats. This is the actual aircraft here with all these fans embedded in the wings. After they flew that, again, about just over a year ago, they announced a 5-seat concept that they're developing. And I should mention that most of these companies are actually competing with Uber or have different models or different things. So there's only actually 5 companies that are actually working with Uber on potential aircraft. This is the flight video that Lilium showed for their, allegedly their first flight, but they announced this is what they released when they announced it. So, I like vertical flights. I just think that's really cool. It just pops off the ground, looks kind of like a pumpkin seed. They have the different fans are in the flaps there for control. So then kind of at the opposite end, looking at the hover platform, it's really kind of a flying chair, right? We talked about Cuisinart, the choppers here. In case you're too tall, you can just get a couple feet of your legs chopped off. Now they only had 4. They said, "Oh, it's really safe because we've got 8 rotors, and 4 sets of 2 blades apiece, and it's 4 posts." It's like, well, helicopters can provide that yaw moment, but a propeller can't since it doesn't have the cyclic control. So if you lose one arm, if you hit something and you knock out both rotors, then you're dead. So they have been flying a couple of variants. So they think this is a single 1-seater, but with twice as many rotors. So instead of it's got then 8 arms and 16 propellers. They've also done a 2-seat, but the information they've released has not been clear as to is this a 2-seat with the 16 propellers or what. But anyway, so they're looking at different things and talking about how safe it is. Kind of then on the opposite side of the spectrum, going from single seat to a 6-seat concept. This is a hybrid electric design. They think they can get a 1,000 nautical mile or 1,000 mile range. So this is more of this is an intra-city sort of a regional biz jet kind of application. They're building a 60% prototype. So these are the ducts for the prototype, which this was a couple months ago, but they're hoping to start doing some flight tests or at least ground tests with their subscale demonstrator later this year. So Uber Elevate. They actually announced this at one of our workshops in September of 2016. We were actually helped contribute to the white paper, so my name is in the white paper they came out with. They had the summit last year. They had a summit this week in LA as our second one. And Uber's not developing an aircraft. They're trying to develop the ecosystem, all the components that would be required to make something successful. So looking at charging, companies developing charging systems, batteries, real estate, obviously aircraft manufacturers, working with cities, working with the FAA and other regulators to try and figure out all the different parts to make this capable. So these are smaller aircraft than a conventional takeoff and landing, but really higher technical barriers, as was described very well. That this is really, really hard, and can Uber actually do all these things and have thousands of aircraft flying in cities in 2023? Well, probably not, right? So I mean, there's each one of these challenges is really you almost need a miracle to have one of these things happen if you want to have it in the next 5 years. But in the next 10 years, yeah, I mean, maybe it won't be exactly like this, but I think there's a good possibility that a service like this could happen if you can get the noise down. Like I said, you can demonstrate the safety, you can have the efficiency. Their whole key to making money is having shuttles. It's not a taxi that's going to come in front of your house. It's a shuttle service that's going to go between different skyports. So if they can keep the load capacity up and have full seats all day, every day, then they think they can make some money. And Uber's shown that they're willing to enter a market and lose a lot of money to establish the capability, the service, and then their plan is to then make money in the long term. So a year ago, we started the eVTOL.news website. So just remember that, and it's not eVTOL.com or org. It's eVTOL.news. And so we have, it's now, I think they were supposed to update it today. So it's supposed to be 75 aircraft concepts were detailed. Obviously, many missions beyond just Uber's Elevate mission. So check that out. We also have from the magazine and other sources, we have about 80 or so news articles as well. So lots of news on eVTOL.news, and then this directory of all the aircraft. And there are only about a dozen or so when I started, so I didn't realize it was going to be so many aircraft. But, so we had started this transformative vertical flight workshops, as I mentioned, in 2014. We had this one recently in January at Fisherman's Wharf. And it was really interesting because you had the innovators, the Silicon Valley guys, the electric propulsion people, battery people, investors, and you had the traditional rotorcraft, helicopter technical experts, and they got each other. It was really neat. You had such a broad expanse. The rotorcraft community has these tools. Ken mentioned, WAP and the PSU WAP that he's developed. We have all these tools for vertical flight, for modeling and simulation and development and design development. And having this tremendous influx of money and interest and enthusiasm is really changing things in vertical flight. This is a little bit old maybe, but from in February, Flight Global had an opinion poll just for people who happen to be on their website saying, our air taxis are on a ride to nowhere, and it says, okay, so 15% said yes, they're going to go somewhere. Third said it's a fleeting gimmick, and 52% it was rank stupidity. So basically 84% said it wouldn't happen. Now, after a 4-day workshop on this and the conference, we asked the question, will eVTOL be operational in the next 5 to 10 years? And basically 60% said yes, they will happen within 5 to 10 years. And we kind of asked, did you think it was going to happen before you got here, and did it change your mind? And so that's what the different things are. No, I didn't think it was happening. No, I didn't change my mind. No, I didn't think it would happen. And yes, sorry. And yes, now I do think it's going to happen. So that changed the mind. So anyway, just very interesting. So again, I mentioned this, all the infrastructure. So ChargePoint is a partner with Uber. So they're looking at charging stations. This is a 2 megawatt connector for charging the batteries because they want to charge the batteries within 3 to 5 minutes or something. So it's got water cool that goes in and cools the battery while they're recharging it. So lots of different ideas for all the different problems. Uber Elevate aircraft partners. There's 5 companies. These are they. Pipistrel had a really interesting concept that they unveiled earlier this week. Embraer also unveiled their concept. Karam Aircraft is an innovative rotorcraft company. They have a new concept. And then Aurora Flight Sciences has tweaked theirs a little bit. Bell hasn't really unveiled their concept. So this is as of January. There are 50 aircraft. So we had the different categories: tilting thrust, lift plus cruise, wingless, hover bikes, or flying chairs. So these are things you usually see on YouTube or something where you're on a saddle. And these are just number of aircraft in these different categories. This is the number of seats. So 1 seat through 6 seats. So these are a number of aircraft designs that are out. And these concepts span the gamut from seriousness. So some are silly. Just somebody maybe spent a few hours doing some CAD drawings or put some motors together and stuck them on a chair or whatever. But some of them, like I said, there are millions of dollars going of investment. In fact, if you look at across all the different aircraft, it's been over $1 billion of venture capital money or investment or development that's gone into eVTOL aircraft just over the last year, and probably about $1.5 billion over the last 4 or 5 years. So very interesting times. If you're interested in more information, as I mentioned, the key one is the eVTOL news. We're on all the different social media platforms. We've got lots of educational videos, so I appreciate, Brian, you guys videotaping this one and help to educate the world on the promise of sustainable aviation. Just very interesting. And on our website, you can sign up. We have a newsletter on eVTOL stuff as well. So that's what I've got. This is likened to, drones. A lot of people, said, even FAA said, there's probably need for a couple thousand drones out there by 2020. And now, there's, 1 million of them that have been registered. So this may be something similar to that. Small aircraft that you can, produce by the tens of thousands of aircraft per year. Like I said, will it happen by 2023? Probably not. But certainly within 10 years, I think there's a good chance it could actually come to pass. So with that, I'm happy to answer any questions, either in any remaining time I have or at any of the breaks. So any questions?
Two quick questions.
Yes.
Why does the Kitty Hawk fly only over water? And number two, how much noise does it make?
So I was not there when they flew. They flew at Oshkosh this past year, and I'll say over water for safety reasons. So they want to sell these to the public, and they wouldn't allow the public to be able to fly these. So it's only safety. It's only for safety. And I don't know how noisy it is. I mean, you can see on our video, we did a video of them flying at Oshkosh. So I don't know. Yeah. They're not planning to operate in cities, so they're less worried about the noise signature. But thanks.
Quick question.
Yes.
Two questions following on from that. The notion that somebody can get on something and fly it X feet above the water and then not expect them to push their luck and go to 200 feet is naive. These people will have to have a pilot's license if they're in a flying vehicle. So that's something that's not being really discussed.
Well, they announced that they have lockouts, so it's all they're very conscious of. They're trying to control it so that people don't do things that they shouldn't.
And people being people will find ways around them. That's a given. The interesting thing though is the noise issue. And whilst somebody may say that a swarm of super bees is going to be quiet, noise is subjective. So somebody could find a V12 Formula One race car, the most beautiful sound you'll ever hear. Other people will think that's the most ear-splitting, painful noise they've ever heard. And that's the problem. It's a case of, I don't quite understand this detachment between helicopter operations and all the helicopter manufacturers there are and the issues that they face, and how these guys, just because they're throwing $1 billion at this, seem to think they're going to overcome these objections to noise, which there are going to be, because none of these so far have demonstrated, and most of them have gone out of their way to hide the amount of noise it's generating. So when does a slightly more realistic perspective start coming in terms of, this is the noise we're creating, this is what we've got to be under in order for it to be acceptable?
Sure. So there are fundamental physical differences that are very different between helicopter noise mechanisms, as Ken explained a little bit, but could can go into great painful detail with. So helicopters fundamentally, with having two rotor blades or a few low rotor blade count, have a specific noise signature that's really annoying. So with having lots of smaller lots of smaller propellers, the noise is less. And there are measurements of the helicopters, the eVTOL aircraft flying. We're actually trying to help put together kind of a coalition to get more data points to actually prove that it will be. But it is fundamentally different. These are not electric helicopters, so they are fundamentally different as far as noise signature.
Just following on that point, with regard to the number of the rotors, there was an image of the A400, I think, was brought up on the screen, the cargo plane. That was meant to be quieter than the Hercules. In certain flight situations, it's now being reported to be at least twice the noise of a Hercules in flight operations. It creates a very high-pitched whine. So in terms of the organization, is there a time frame for when we expect to have the noise requirements effectively that's acceptable by all cities and that sort of thing? Has that been looked at?
Well, all helicopters meet all requirements for noise. So that's the problem, because the subjective noise from people that complain is much less, right? And some of it is virtual noise, where people just see helicopters and it annoys them, so they complain about it. So no, there's not going to be a worldwide or a national standard on helicopter noise. And again, there's not a lot of test data for developers to prove this. But but it is. To date, the empirical evidence suggests that it will be much quieter, we know that the Uber eVTOL aircraft will not be loud because they will not exist if they're loud. So that is the linchpin. They cannot operate off these rooftop helipads if people are going to object to them. So it's a binary. They're either going to be quiet or they won't exist.